Hello, everyone. My name is Nicole Paz Bracamonte, and I am in Dr. Jason Schwantz's lab at Cal State Long Beach. My research is titled Incorporating Substrate Features in FMOC Amino Acids to Develop More Potent and Specific Butyrylcholinesterase Inhibitors for the Potential Treatment of Alzheimer's Disease. So my abstract, so what is Alzheimer's disease? So Alzheimer's disease is a chronic neurodegenerative disease that leads to irreversible memory loss and is the most common form of dementia. Currently in the US, it's the sixth leading cause of death. Unfortunately, there is no cure for Alzheimer's disease, but there have been many different approaches on how to mitigate these symptoms. One example is that in our brains, there are two classes of cholinesterase enzymes, acetylcholinesterase and butyrylcholinesterase. These enzymes are the ones in charge of hydrolyzing the neurotransmitter acetylcholine. So in normal brain function, acetylcholine binds to a receptor in the synapse and initiates a response, which triggers like a response. And what would happen is that then the acetylcholinesterase enzyme would then bind onto the neurotransmitter acetylcholine to hydrolyze it and therefore ending the signal. So that is how signals are passed through our synapse. However, with patients with Alzheimer's disease, these signals aren't seen as much, which is why they are having these forms of dementia and memory loss. And the reason behind that is because the second cholinesterase enzyme, butyrylcholinesterase, or butchase for short, actually it has seen that the concentration, the amount of butchase has increased in patients with Alzheimer's disease. So the hypothesis is that butyrylcholinesterase is now taking up this substrate, the neurotransmitter, and is preventing it from binding to the receptors in the synapse, which therefore is causing for no signal to happen in the brain, or very little amount of signal. So with this information, in my lab, they wanted to test inhibitors that could inhibit butchase enzyme and see what if there's an inhibitor that's specific to inhibit only butchase and not HAs. Previously in my lab, it was found that FMOC lysine, an FMOC amino acid derivative, FMOC lysine, was a potent inhibitor. So here we see that HAs and butchase are superimposable onto one another. So we wanted to test an inhibitor that would be specific to butchase. And as I said, FMOC lysine showed promising results. However, it is seen that the neurotransmitter acetylcholine has a positive charge and 3 methyl groups right here. And FMOC lysine has no methyl groups. But my hypothesis was that if we're trying to mimic the properties of the neurotransmitter, how would it work? Would FMOC lysine be an even better inhibitor by adding methyl groups to the amino part of lysine, which would therefore be very similar and mimic the methyl groups on acetylcholine? So this leads into my procedure. I needed to synthesize first the dimethyl analog of FMOC lysine and then add the third methyl group in a 2-step synthesis. Therefore, characterize it by NMR, determine an inhibition constant value for butchase inhibition, and finally evaluate specificity for butchase or HAs. Okay, so for my synthesis, we began with FMOC lysine. And again, this is a 2-step synthesis. So I first have to add 2 methyl groups and then finally the add the third methyl group. So in the first step, I'm using 37% formaldehyde, keeping the pH between 3 and 6, as well as using acetic acid and the reducing agent sodium borohydride to then get the 2 methyl groups. And then in my second step of the synthesis, using methyl iodide and DMF and water to then add the third methyl group. However, I have been facing a lot of challenges with adding the third methyl group for FMOC lysine. So in terms of the rest of my results, Dr. Schwanz and I decided to test how FMOC lysine with the 2 methyl groups functioned as an inhibitor. And I'm still working on getting the third methyl group onto FMOC lysine. After I did the first step of my synthesis, I characterized it by NMR, and I saw this peak right here labeled and shown in this orange arrow that corresponds for the hydrogens in the methyl groups of the amino part of lysine. So this was further confirmation that I was able to successfully add the 2 methyl groups. From there, we did 2 enzyme assays to determine the Ki value. So first, in this graph, we're showing the absorbance versus time. So for each decreasing line, we're increasing the amount of inhibitor. Then we took those slope values and plotted them in this graph of absorbance versus time to then calculate an inhibition constant value, which is known as Ki value. So as I said previously in my lab, it was found that FMOC lysine functioned as a good inhibitor, and its Ki value was 150. Now, with just me adding the 2 methyl groups, the Ki value decreased to 40, which means that FMOC lysine with the dimethyl groups added is a 4-fold better inhibitor than FMOC lysine without the 2 methyl groups. So the lower the Ki value, the better of an inhibitor this is. So these results were very promising already as it is with just the addition of the 2 methyl groups. Finally, we compared butase and ACE inhibition to determine if the FMOC lysine, the dimethyl groups, was specific to butase. On the left here, we see an absorbance versus time plot. And in black, we have butase minus the inhibitor. So we're seeing its normal activity. And then in red, we're shown the butase plus inhibitor. So we see that its activity, as we know, decreases a lot and inhibits the enzyme. But now with HAs, we see that with or without the inhibitor, the activity of the HAs enzyme stays the same. So therefore, showing us that the FMOC lysine is specific to butase, and furthermore, the FMOC lysine with the dimethyl groups is specific to butase and is lowering butase activity, which is very promising. So for future directions, I want to successfully synthesize the trimethyl group, which is something I'm working on currently as my last semester at Cal State Long Beach. And then after that, make additional modifications, including an ester or an amide, and seeing if the bulkiness is of the compound is what is making this an even better inhibitor and specific to butase. And finally, testing for other enzyme specificities to see if FMOC lysine with the dimethyl groups or trimethyl groups is specific to butase and has no effects on other enzymes, which is a problem that we see a lot in medicine, which is that it inhibits one enzyme but shows that it can cause effects to another enzyme inside the body. So this would be the next steps. So furthermore, in conclusion, I was able to successfully dye successfully methylate FMOC lysine by adding 2 methyl groups to the amino part of lysine. I was then able to test for inhibition on butase, and I found that with just the addition of the 2 methyl groups, it functioned as a 4-fold better inhibitor, and therefore then tested for specificity to see if it was FMOC group was specific to butase, and it was. So therefore that with just the addition of the 2 methyl groups, it was seen that it became an even better inhibitor for the enzyme butase, and which is very promising and leads us to hopefully believe that with the 3rd addition, it would be an even better inhibitor. So here are my references, and I want to acknowledge HSI STEM for their award, for giving me the award, as well as CSU LSAMP for also funding my research, and to Dr. Jason Schwanz for all his help in my project. So this is my poster. Sorry. So this is my poster. I have presented this poster. Let me just kind of talk a little bit about my time at Cal State Long Beach. So I am a senior at Cal State Long Beach. I'm currently in my spring semester, my last semester at Cal State Long Beach. I'm a transfer student, and I have presented my research at a couple conferences already, one of them including SOCNAS. So it was during the fall of 2020, so that the presentation was completely online. Everything was completely online. I had 2 judges, and they were both very, very sweet and very welcoming and made me feel very comfortable. I just really enjoy presenting my findings, especially because my results are very promising, and yeah, SOCNAS was great. I mean, any conference that you have the opportunity to go to is like a great experience, especially being able to just attend the various talks and go to the various schools that are there to talk to people, especially in admissions for graduate studies or medical schools that do end up going. The SOCNAS conference was honestly one of the best conferences I've been to. Not only were the judges very welcoming, they were very great at making me feel comfortable, because it is very nerve-wracking to present, but they asked very, very great questions, and both of them both of the judges were just very sweet, and I honestly had one of the best experiences at SOCNAS. On top of that, I had seen that I'd gotten an award for my presentation, for the outstanding research presentation, which was really honestly unexpected. And yeah, I totally completely recommend all of you to really take the time to apply to the various conferences, especially SOCNAS. I think it's something that not only is a great way to practice, your speaking skills, but also practice talking about science to other people. And the judges, although they were they were biochemists, they hadn't heard of this type of research before, so they were both very interested. And the other presentations I had been to, everyone was very nice and great. So thank you for listening to my presentation. Good luck to you all. And if you have any questions on my presentation or any other questions, you feel free to contact me. I will give Lark my email, therefore you guys can feel free to email me. Have a great day, you guys. Thank you.